Hi, welcome to the channel. I'm Mrs. R. Let's do some math. Hi there. Today we are working with proportions. Now, proportions can be something that you are assigned and studying just on their own. Just here's a problem that looks like a fraction equaling a fraction, and one of the pieces is a variable. Or it might be part of a bigger lesson. So proportions are going to come into play with a lot of things in math. So getting comfortable with them by themselves is so important. So let's look at solving proportions. Anytime it's a proportion, you're going to be seeing a fraction on both sides of the equation. That's just what a proportion is. Now, there's lots of ways to look at this. One of the most common things that people say with solving proportions is that you should cross multiply. And I'll be honest, I don't particularly like that phrase because it's really easy because of the word multiply and you're seeing two fractions to get this strategy and this process mixed up with multiplying fractions. And it's not at all the same. It doesn't do the same thing. We are working with proportions. I do not like to say cross multiply. I like to consider this like just any other algebraic equation where I want to isolate the variable and see what it's equal to, right? So this is one of the more straightforward kind of ones. I find my variable first. Here's my variable, it's an x. And I see that with the x, I have a divide by 3. So I use my inverse operations, and I'm going to multiply by 3 on both sides, multiply by 3. Since we are dealing with fractions here, if you wanted to do times 3 over 1, then that's absolutely fine. But as you consider the x times 3 divided by 3, those are going to cancel out. On the left-hand side, we are dealing with the fractions, right? So we'll multiply across the top. 3 times 7 is 21. And then 1 times 5 is 5. And that would just be our answer. 21 over 5 equals x. Now, you could divide that out if you need a decimal answer. That's totally fine. Divide it using long division or your calculator. But we have isolated x. We have a plain number on the other side. That's kind of the easy version of this. There are obviously other ones that get a little more awkward. Really where they start to kind of mess with people is when your variable, when you go to locate your variable and it's in the denominator of one of your fractions. So for example, let's say we have 4/3 is equal to 8 over x. So you locate your variable. I see it here. Now this says 8 divided by x. So when we're trying to isolate x, we actually can't get x quite by itself yet because the best thing to do is to get your variable out of the denominator. That's number one thing. You don't want to leave a variable in a denominator if you don't have to. So instead of trying to work with getting rid of the 8, I'm going to move the x to a better spot. So since it said 8 divided by x, I'm going to multiply by x. I'm just going to do that on both sides. Now this is x over 1, if that helps you. Now, you're going to think that this is crazy and I haven't actually done anything to help. But our x's do cancel because now this is 8 times x divided by x. That's going to get us down to just regular old 8. And on the left-hand side, we have across the top x times 4. So we get 4x there. And then we have a 3. So you're right. This doesn't look that much better. We still have a fraction. Our x is definitely not isolated at all. But it's not in the denominator. And that is so much easier. And you'll get to a better looking answer anyway. So now that we have our x in a good spot, now we can continue isolating. And first thing I always do when I have fractions in my equation, when I have a fraction equal to something, I'm going to multiply by the denominator. So multiply by 3. If it makes it easier for you to do the over 1, then that's fine. But on the left, those 3's do cancel to 1, leaving us with 4x. And then on the right, we get 8 times 3, which is 24. And now it's just one more step to isolate that x. 4's cancel to 1. I get x equals 6. And then that's perfect. That's what we were looking for. There are other ways to look at these, yes. but some of the tricks that work sometimes won't work always. So this is a method that will always work. Now you can save yourself some time. Let's look at that 4/3 over 8x. We know the answer is going to be 6. But another way to look at proportions is kind of what change are we making? And this is when you start to do similar figures eventually in a geometry class, or rates of change or things like that. How does the 4, what can we multiply by the 4 to get to 8, right? That's something we can think about. Well, we multiply by 2. 4 times 2 is 8. So if we do the same thing with the 3, multiply it by 2, that gives us x equaling 6, which we know is already right. Now, that's kind of a nice trick. It's a nice sense-making tip, but it doesn't always fit because, for example, if we have something, let's do another one where it says 2 over 11 equals n plus 3 over n plus 7. We can't just say, okay, well, 2 times what gets us n plus 3? That's not going to work. For this one, we really would need to do our whole strategy of multiply by the denominator, right? Here, they're just going to cancel. You don't have to worry about getting any crazy multiplication happening there. We do need to distribute, though, since we have 2 times the quantity of n plus 7. We'd have to do 2n plus 14. That's still over 11 equals just the n plus 3 over there now. And then, again, we still have a fraction. We don't want these fractions in here. The whole goal is to clear out the fractions. But this is definitely looking like one of our multi-step equations, right? There's lots of steps to do. So I'm going to multiply by 11 over 1. So our 11s are going to cancel here. We've got 1 in the numerator, 1 in the denominator as factors. Over on the right side, we do need to be careful. We're multiplying this entire side by 11. So while the left side is getting less complicated, 2n plus 14, the right side we have to distribute this 11. So this is going to become 11n plus 33. And now this really looks like one of our multi-step equations. So I'm going to, let's see, maybe subtract 14. So we'll get 2n equals 11n plus 19. Then we can subtract 11n, get those n terms to the same side. 2 minus 11 is negative 9, so this will be negative 9n. And then we divide by the negative 9. And then my n is going to equal negative 19 over 9. So definitely not a fun answer, not an easy answer, but it's something where we can work on that. We can divide it out to a decimal if you need to, or it's a simplified fraction. Improper, yes, but simplified. So that is a fine answer. So that was kind of definitely a more complicated version of solving proportions. There is, remember, this little trick if it's all seeming like the numbers fit together easily in your brain. But here's our main idea of multiplying by the denominators, then isolating your variable. So hopefully this helped you. I would not get caught up on the verbiage of cross multiply. I would think about, okay, here's a fraction. I don't want there to be a fraction. Let's multiply both sides by the denominator, and we'll clear some of those fractions out slowly but surely. Just take it step by step, and you will get to your answer, even if it's something crazy like negative 19 over 9. So thanks for watching. If this video was helpful for you, please hit the like button. That helps us make more videos. If you still have questions or you want to see another concept, leave a comment for me. I'm Mrs. R, and this has been Me Doing Math. I'll see you next time.